My name is Ria, and today I'll be teaching you all about acids and bases. So, to start off, I'm Ria, or Ria Cheng, and I'm a first year student at the University of Toronto, currently studying neuroscience and economics. Today, we'll be learning all about acids and bases and how to make your very own cabbage pH indicator. Okay, our agenda for today. We're going to learn these concepts, right? So acids, bases, pH, and pOH, and what they mean. We're going to apply these concepts by making our very own cabbage pH indicator, and then we're going to reflect on what we've learned by testing out the indicator solution. So you're going to tell me which substances are acidic and which substances are basic. All right, so to start off, what are acids? So an acid is a substance that produces hydrogen ions and water. Because it produces hydrogen ions, they can also donate hydrogen ions in solution, right? This might seem like a very hard concept to grasp, but I'm sure all of you have heard of acids before. So let's think of lemonade as an example. When you drink lemonade, it has a very sour, tangy taste without sugar, right? That sour taste is a result of acidity. Lemonade is acidic because it has a lot of hydrogen ions in it. An ion is a special type of molecule that has an electric charge. So, hydrogen ion has a very tiny electrical charge. And when there's a large amount of hydrogen ions present in something, that substance is acidic. So, as I said before, hydrogen ions have a tiny electrical charge, and so acids can conduct electricity. They have a pH less than 7. We'll talk about what pH means later on. And acids have a sour taste, a stinging feeling, and are corrosive. So, some common examples of acids. We have vinegar, tomatoes, Coke, and citruses, which include oranges, limes, etc. So the actual scientific name for vinegar is acetic acid. That is a weak acid. And for citruses, the scientific name of the acid is citric acid. All right, so what are bases? A base is very similar to an acid, but the ion in question is hydroxide ions and not hydrogen ions, right? So a base is a substance that produces hydroxide ions in water. They can also accept hydrogen ions in solution. So let's think of baking soda as an example. Baking soda is a common leavening agent used in the kitchen, right? So it's used to make cakes, cookies, etc. rise. Have you ever accidentally tasted baking soda before? It's very bitter, right? And it has a sort of soapy, strange feeling when you rub it between your fingers. This is because baking soda is a base. Basic substances have a lot of hydroxide ions, and that's what makes baking soda basic, right? It has a lot of hydroxide ions in it. Bases can conduct electricity. They have a pH greater than 7, and they feel soapy or slippery. They have a bitter taste and are corrosive. So here are some common examples of bases. We have baking soda, as we said before. You have detergents, laundry detergents, right? Your floor cleaners and your soaps. So notice how most of these options aren't food, right? We don't really have a lot of bitter foods in our diet because most of us don't like eating things that are bitter, and so most of our diet consists of acidic and neutral foods and not basic foods. All right, so how do we measure acidity and basicity? So let's start off by talking about the pH scale. So the hydrogen ion concentration, as you can imagine, is a very small number, right? And so this is very hard to deal with. In order to make it easier for us, we convert this number into a large one by using the idea of pH. So pH is the negative log of the hydrogen ion concentration. So if your H plus concentration is 10 to the negative 8 molar, then you would take the negative exponent of that, right? So the negative exponent of negative 8 would be 8. So pH would be 8. So if you have a pH less than 7, that substance is acidic. If it equals to 7, it's neutral. And if it's greater than 7, then it's basic. The greater the hydrogen ion concentration in the solution is, the more acidic it is. So when we have a strong acid, that's completely ionized, which means there's a great amount of hydrogen ions present, which means that there is a low pH since they're inversely proportional. And similarly, when you have a weak acid that's partially ionized, you have a low H plus concentration, and so you have a high pH. All right, the pOH scale is something that we use to measure hydroxide ion concentration. It's less commonly used, so you most likely won't encounter this a lot. All right, so it's very similar to pH but instead we convert the hydroxide ion concentration, right? So pOH is the negative log of the hydroxide ion concentration. Similarly, you take the negative exponent, so that would be pOH equals to 6. So strong bases are completely ionized, which means that there are a large amount of hydroxide ions present, so there's a low pOH and a high pH. And for weak bases, they're partially ionized, so you have a small amount of hydroxide ions, a high pOH, and a low pH. So I hope that was clear. All right, so now we'll do our little activity. So to start off, we need to gather our materials, right? We're gonna need a small red cabbage, lemon or lime juice, vinegar, some other foods to test, such as egg whites, tomatoes. You can also test something else like baking soda solution or things like soda pop, etc. We're gonna need little containers. So we're gonna need small white paper cups or plastic cups, etc. As long as you can see the color. Right, we're gonna need a grater, a strainer, boiling pot of water, a large bowl or pot. We need two of those, two large bowls or pots, and a bleach cleaning product if you want to test out bleach. So to start off, we're going to need our indicator. Remember that you should always wear protective eyewear if you want to be careful, and you should also have an adult supervise you when you're handling the grater and the boiling water. And if you decide to test out bleach, you should also wear gloves. So we're going to start off by grating a red cabbage, and then we're going to put the grated cabbage into a large bowl. And then we're going to boil a pot of water, and then we're going to put that water into the cabbage pulp until the water covers the cabbage. And 3, we're going to let this mixture steep until the liquid is room temperature. So this takes about half an hour. And then we're going to get another large bowl and strain the cabbage mixture to remove the pulp. This is what the steps look like, right? So we have the pulp, you add boiling water into it, you strain out the pulp, and then you get your indicator solution, which looks like this. I've done the steps beforehand because the process is very lengthy. So step 2, testing. All right, so I went ahead and added a tablespoon of the indicator solution into my cup, and you tell me, what is the color of the solution? If you said purple, you would be correct. All right, so now we're gonna add a few drops of lemon or lime juice to the solution until a color change can be seen. I'm going to add my lime juice into here. I'm running out of lime, so let me just get a little bit more. Okay. So we're going to add your lemon or lime juice into the solution until a color change can be seen. Now, do you see this? What color is that? That looks reddish pink, right? So the color of this indicator solution is going to change based on the pH, right? So in this indicator, if it's red or purple, that indicates an acidic solution. If it's purple, that's neutral. If it's blue, blue-green, or greenish yellow, it's a basic solution. But based on the color, is lime acidic, neutral, or basic? If you said acidic, you would be correct. All right, so we can test out some other foods as well if you want. We can test out egg whites, tomatoes, clear soda pop, etc. So just make sure that your food is in liquid form. So you should crush and dissolve the food if it's not in liquid form and add some water just to make it a solution so that it's easier to test. All right, so now we're gonna test some more. So I have another cup with my indicator solution. Now we're gonna add drops of vinegar until a color change can be seen. Okay, so let's see. Add your vinegar. Do you see that? Okay. What color is that? That's reddish pink, right? So because it's reddish pink, it means that vinegar must be an acidic solution. Okay. So now we're going to test bleach. Since I don't have bleach with me right now, I'm going to test something else. I'm going to test baking soda solution. So I dissolved some baking soda in some water. I'm going to test that instead. So I have my indicator solution. I'm going to add the baking soda. Can you see that? It turned green, right? So because it turned green, what does that tell us about the pH of baking soda? All right. So because it turned green, it means that baking soda is basic, right? Because it's basic, it means that it must have a pH greater than 7. So we've talked about acids, bases, pOH, and pH, and I hope that you were able to learn something today and that this presentation was helpful. So thank you so much for listening, and I hope to see you guys in person one day. Bye!